This video reviews all the algebra you'll need to know from Chapter P. Chapter P started out with exponential functions, and a typical problem on the final might be xy to the negative 1 z cubed, in which case you might consider cubing everything first. So that would be x cubed y to the negative 3 z cubed, but then taking the exponent that's negative and that portion of the graph that portion of the problem flips down to the bottom. So this would be equal to x cubed z cubed divided by y cubed. Students tend to do pretty well with that, but then have a harder time when there's more flipping involved. And so you really need to sort of break down the pieces of the problem. In this problem, the 2 right here on the bottom is going to stay on the bottom, and the x right here on the bottom is going to stay on the bottom. But this m that's on the bottom is to the negative 4 power, so the m to the 4th is going to travel up to the top. Another thing students forget to do is when they have an exponent outside the parentheses, they forget that it applies to everything. It applies to the 3, it applies to the x, and it applies to the m. So really the 3 is going to be to the negative 3, the x is going to be to the negative 3, and the m is going to be to the negative 6. What that means is this 3 to the negative 3 power is going to travel down to the bottom of the problem. And 3 cubed is 27, so there'll be a 27 on the bottom. The x to the negative 3 is also going to travel down to the bottom, so it'll be x cubed. And then the m to the negative 6 is also going to go down to the bottom, so it's going to become m to the 6th on the bottom. And then you'll have to simplify that more. You have 2 times 27 on the bottom of the function, and so that'll be a 54 on the bottom. The m to the 4th and m to the 6th are going to cancel, and you'll have an m squared on the bottom, and you'll have an x to the 4th on the bottom because you've got this 1x here and these 3x's here, and with nothing left on top, there's your solution. And so anyway, the most common things are, like, when you look right here, the m is to the negative 4, but the 2 is not, so the m moves, but the 2 doesn't. When you look at the top, because of the parentheses, everything is taken to the negative 3 power. And sometimes, it's kind of a weird thing, but even with a basic problem, like 2x squared cubed, the solution to that is 8x to the 6th, and a lot of students will look at the x squared and they'll cube it, and they'll forget about the 2. So don't forget, if it's in parentheses, the power applies to everything. In problems like these, you need to multiply everything by the common denominator. And what I saw in people, what I saw a lot of you guys doing when you were working on the review is instead of multiplying by the common denominator, you got a common denominator. Like you multiplied this first term by 3 over 3. 3x or 3 over 3x, and you got 3x squared over 12x, and multiplied the second term by 4x over 4x, and got negative 8x squared over 12x, and multiplied the last one by 12 over 12. And got 12 over 12x. Now, you can do that step, but I want to show you an easier way to do it. If you take the x over 4 and times it by 12x, this cancels, and you just end up with 3x squared. And if you take the negative 2x over 3 and multiply it by 12x, the 12 over 3 cancels to 4, and you end up with 8x squared. And if you multiply this last term by 12x's, the x's cancel, and you get 12. And so what I want you to do is look at this, what most of you are inclined to do, and look at this, and by doing my steps it doesn't have any fractions. Now, if you're just completely tied in to I have to do it my own way, that's okay. This is okay. But you need to recognize that if you have the same thing on the bottom all the way across, you can just cancel it, and your next step will be negative 5x squared equals 12. This would be x squared is equal to 12 over negative 5, and this has no real solutions because you can't take the square root of a negative. In this next problem on the test, you'll have to recognize how to graph absolute values. If you're going to do this algebraically, you would start off with 2 minus x is greater than 3, just like it looks. But when you take it and you switch the positive 3 to a negative 3 to write out the other half, you have to switch the greater than to less than. And then if you solve both sides, you'll end up with negative x is less than negative 5, so x is greater than 5. Or you'll end up with, I think I copied something down wrong here, 2 minus x is greater than 3. Or you'll end up with, subtracting 2 from both sides, negative x is greater than 1, so x is less than negative 1. And or you can memorize that, greater than graphs always end up in two different directions. So this graph is centered at positive 2. If I go to the right 3, I'm at 5. If I go to left 3, I'm at negative 1. And this graph goes in two different directions. On your test, this will be an interval notation, so it'll say negative infinity to negative 1, union 5 to infinity. In chapter P, you will have to be able to find the equation of a line. If you had f of negative 1 is equal to 4, and it told you that f of negative 3 is equal to 7, then the first thing you would have to do is recognize that this is the point negative 1, 4, and this other point is the point negative 3, 7. And you would find the slope, and to go from 4 to 7, you have to go up 3, and to go from negative 1 to negative 3, you have to go to the left 2, and the slope is negative 3 halves. After you get the slope, you write the equation y minus the y point equals the slope times x minus the x point, and depending on which version of the test you have, you may have to write that in slope-intercept form, which will involve solving for y. Or you may have to graph it, you have to give the solution in standard form. Let me finish up this one. 4 minus 1.5 is 2.5. And I'm going to run out of room right now, so I'm going to make these smaller. So I found the slope. This right here is my point slope form. I got it to here to slope-intercept form. I would need to multiply everything by 2. So that's 2y equals negative 3x plus 5. And move the 3x over. 3x plus 2y equals 5. That's standard form. Now this is a little bit easier because you have these equations up on the wall in my classroom, but remember to pay attention to what form it asks you to give the answer in. You will have to be able to solve a quadratic both by the quadratic equation and completing the square. If you were using the quadratic equation, it would be x equals 5 plus or minus the square root of negative 5 squared, which is 25, minus 4 times 2 times 6, all over 4. This is 5 plus or minus the square root of 25 plus 48, because, 25 minus 48, which took me an extraordinarily long time to do, negative 23 over 4. So this would have no x-intercepts. Although, if you had to find the vertex of the graph, the x value of the vertex is right there. Another way to do this is by completing the square, and I'll show that one over here. So if you were to complete the square, you would make it equal to 0. You'd move the 10 to the other side. You would take 4 divided by 2, square it, that's 4, and add it to both sides. So that's 14 equals x minus 2 squared. Then you would square root both sides. Don't forget your plus or minus, and x would be equal to 2 plus or minus the square root of 14. Now, this is also going to be useful on the portion of the test where you're required to make a graph, because if you were going to graph that function, you would know that it's centered at an axis of symmetry of positive 2. You would know that the intercept was at negative 10. You know this graph goes up, and if you plug 2 into the equation, you get 4 minus 8 minus 10, and that's negative 14. And so this graph has a point at 2, negative 14, and then it's plus or minus the square root of 14, which is a little less than 4, because the square root of 16 is 4. So 1, 2, 3, 4, a little less than 4. 1, 2, 3, a little less than 4 to the left of right of that center. Now the graphing is actually a chapter 1 problem, but knowing how to solve this, keep in mind that this part of the answer is the axis of symmetry, which is the x value of the vertex in a parabola.